Right, so welcome to the third lecture. Today I'm going to talk about the next lab sheet that we'll have to deal with when we get into the labs. And the topic of this particular lab sheet is routing. So far, from the first and second lab sheet, you will have created your virtual server, essentially, Prometheus, so the virtual machine that you will be doing everything inside. And then in the second lab sheet, you will have built your little virtual network that will look something along those lines. So you will have your Prometheus virtual machine. You will have two virtual network cards on Prometheus called VMnet 0 and VMnet 1. They will be working on subnets 30 and 31 respectively, and they will be connecting you to two virtual machines, VP0 and VP1, on subnets 30 and 31 respectively. The VP1 will also have two network cards onto it, and it will connect to another virtual machine next to it using the VMnet 2 network card, and that will be on subnet 32. Now, once you're finished building all of these virtual machines, you will have your network, and your network will consist of four distinct subnets. So you will have subnet 28 that gives Prometheus access to the outside world, and then you will have your internal virtual subnets, which will be VMnet 30, 31, and 32. Now our next problem is to actually give internet access to all of the machines in our network, and that of course includes our virtual networks as well. In order to do this, because all of the machines are on different subnets, we need to have some sort of way, some method, in order for your computers to know how to pass along information, how to pass along traffic from one network interface to another. So for example, when vPrometheus 1 needs to go out to the internet, it needs to know that its default gateway to the internet is through VMnet 1, and that VMnet 1 network card on vPrometheus 1 takes it to the Prometheus virtual machine on his own VMnet 1 network card, and that information can be forwarded to the outside world. The outside world being subnet 28, which is the physical network card on your Prometheus virtual machine. In order to achieve this, we need to have some sort of routing in place. Now, routing is the process of receiving packets from any network onto one interface and knowing how to forward them onto another network on another network interface. Essentially, it is the most important function that has to be performed on a network. Okay, when you are sitting on your computer at home and you're typing www.google.com on your browser and you hit enter, by the time the contents of the website actually come back to you, a few hundreds or possibly thousands of routers have made decisions for you on how to actually route that request that you've sent from your computer and all of the information all the way onto Google servers wherever they may be on the globe, and then from there on get the information back onto you. We do this by building routing tables. There are two ways to do this. There's the static and there's the dynamic method. The static routing method is not really used that much anymore. The only scenario where it would be used would be a network that is relatively small and is of very, very, very high security and importance. So you could have this in a military application, for example. You have your routes declared statically onto the systems. You tell them that, if you want to go from point A to point B, you follow that route and that's it. Okay. However, that is very unhelpful for 99.9% of the rest of the traffic on the internet. We need to have dynamic routing. We need to have a method for all of the routers on the internet, all of the routers in a network that make decisions about packets, destinations, and origins, that needs to be able to adapt and change. Your network topology might change. You might shut down one of the routers in the middle of the network. Something might go down by accident. Our favorite cause of this is a JCP digger. Someone might have been attacked, and so on and so forth. So we need to have dynamic routing in place. We need to have a program that is running on a device, usually a router, that sees all those changes and gets informed about all those changes, and always, no matter what the changes are, knows how to actually get from point A to point B. In our case, what we will do, in order just to play around with the basic principles and see how routing works, we will set up routing as software onto our computers. So we will install a routing daemon, as we call it, which is called FRR, and we will install it on Prometheus itself. And then once that is working, we will also install it on vPrometheus 1. Can anybody tell me why we have to install it on Prometheus first and then onto Prometheus 1? Remember, Prometheus has internet access already, it's directly connected to the outside world, whereas VP1 doesn't. Any ideas? Yes? It basically needs to get the software from the outside world, from the internet. All right. So it needs to have a way to actually get the packages to install them. But even if that wasn't the case, if let's say we brought the packages onto a USB drive and we installed everything on one, then it would be useless because you would be able to route from 1 to 2 and from 1 to Prometheus, but then you wouldn't be able to know how to actually go out further than Prometheus. Okay, because Prometheus doesn't have routing itself, and Prometheus is also running on 3 different subnets. Okay, so we're going to install it on the host completely, go through the entire process of configuring the files that we need to configure, install, run it, and test it, and then we'll need to install it on vPrometheus 1. So how do we actually do this? Installation on Prometheus is very simple. First of all, you need to make sure that you have internet access on your Prometheus, which you should by default, and then you do yum -y install FRR. So the -y means yes, so it will ask, I found these packages, do you want to install them? And then it will automatically say yes to itself and just run through the entire installation. And then once you do that, you will need to edit the FRR daemon configuration, which is in etc. FRR daemons. That is basically a configuration file that explains everything that needs to be explained about the software, and in the first few lines of that file, it lists all of the routing protocols that it can do, BGP, OSPF, and so on. You will be using OSPF as your routing protocol in this case, so all you need to do is go into that file and change the no next to OSPF into yes. This means that your routing daemon, the program, will know that it's going to be using the protocol of OSPF. Once you do that, you will need to have an frr.conf file. So you need to have a configuration file for the routing protocol itself. That configuration file exists on Moodle, and it looks like this. Can you read it? All right. So what we have here is a simple configuration file that tells us the networks that we want to be routing through our computer. So in our case, we're working on Prometheus. So the first line that we have there says router OSPF, so we're using the OSPF protocol. The second line says OSPF router ID. So we need to tell the routing software which computer is actually going to be doing the routing. In our case, that's Prometheus. And the preferred IP address out of the 3 IP addresses of Prometheus will be the one on subnet 28. So you should all have their 148.197.28 something, and the something will be the IP address of your network card on Prometheus on subnet 28. It will start from 51 and it will go up to 98. Okay, so this way you're telling the routing protocol which is the router in the network. After that, we have 3 lines. We have 3 network declarations, as we call them, 3 network statements. Now, these 3 network statements is the information that is being transmitted between different routers on a network. So when your Prometheus is running as an FRR router, it will talk to other neighbors, so it will talk to other routers in your neighborhood, namely Columbus, which is our router and gateway in the lab. And it will tell to Columbus, look, I have 3 networks onto me. I have subnet 28, subnet 30, and subnet 31. This way, Columbus will exchange information with your Prometheus VM, and then Columbus will know all of the routes that are available to your private network through your Prometheus. So if Columbus gets information about the packets going onto subnet 148.1.7.30.42, then it will know that it needs to contact the specific computer that actually owns this network. All right, and the only way for it to know this is by having this information given to it from the frr.config file. So what you actually have in this file, you should have the first line, which is network 148.1.7.28.0/23, and this line should be identical for all of you because you're all connected on subnet 28 that talks to your actual physical lab. And then you will have your subnet 30 and 31 that you need to share as information to all the other routers around you. Those lines there will need to have the network address of your system. Your network address can be found in the a2.net subnets file, which is that little chart that we used in the previous lab sheet in order to figure out what IP addresses belong to our computers so that we can use them. So your network address for 30 and 31 will go there. Once you have this information inside it, you can then move on to the next part. So you can go and you can enable packet forwarding. So by default in Linux, packet forwarding is disabled on your systems as a safety measure, as a security measure. Okay, you will need to enable it, and it's very simple to enable it. You start in terminal and you type either this command to enable it permanently or the echo command, which will enable it temporarily until you restart the network or you restart your Prometheus VM, and you can use this if you want for testing purposes. Once you've enabled packet forwarding, you will need to allow FRR through the firewall. So you type the firewall command that lets it through, and then you restart the firewall itself. Once you do all that, you then restart and enable the FRR service. System restart will basically restart the service, and system enable will set the service so that it starts automatically every time you boot up your computer. So once you do this, then you have pretty much configured routing on your Prometheus. Now on to testing. So in order to make sure that routing actually works, the first thing that you can do is type the command watch root -n in a terminal. This command will stay in the terminal and will actually take over the terminal, and you will not be able to type any other commands, and it will give you a dynamically updated version of your routing table. So it will show you which routes your computer actually knows about. When we're doing this lab, I will do the same command on Columbus itself. So another test for you to see that your routing actually works is if you are able to see your networks on the projector, on Columbus's routing table. So this will mean that you are advertising your networks correctly onto your next available router, which is Columbus, and then by having more routes available on your own routing table, you'll be able to see that you're actually receiving information from Columbus and from other routers in the lab, and you can actually route to those networks from there on. There are various commands that you can do or type in order to play around with this. So you can do show IP OSPF neighbor, you can do show IP OSPF route. I want you to try these commands out, and I want you to look up these commands, how they work and what do they actually show us. And I want you to make sure that you understand these commands. Okay, and you will need to write what these commands actually do and what do they mean and what it actually shows us on your logbook. The last test is actual internet access. So you should be able to ping google.com from virtual machines 0 and 1, because now you have routing on Prometheus, so you should be able to have full internet access onto your virtual machines as well. You should also be able to ping from vPrometheus 0 to vPrometheus 1, because they are not neighbors. You have to go through subnets 30 to 31 to contact each other. So if your routing is working correctly on your host, then you will be able to ping each other. Once you do that, you need to repeat the process onto vPrometheus 1. So yum install FRR and so on and so forth. You configure the configuration files. The only difference is this time will be in the networks that you're sharing. So if we go up here, Your FRR conf on Prometheus will need to have subnets 28 that connect you to the outside world, networks 30 and 31, because they are the networks that exist and are directly connected onto your computer itself. You will also need to configure this on vPrometheus 1, but the difference on this one will be that there will be no subnet 28 statement anymore, because it's not connected onto VP1, yes? And you will only need to have 2 lines instead of 3, so you need to explain to everybody around you that you are sharing network 31 and network 32 from your routing. Once you do this, and once your routing actually works on vPrometheus 1, you go on to testing again, and you do watch root -n. You should see all of the rest of your networks from your system show up there, and you should see everybody else's from the lab as well. And also on the projector on Columbus's routing table, so on our club's main router's routing table, you should be able to see all 3 of your subnets, 30, 31, and 32 up there. Once you have that, then that means that you have achieved full routing on your little network, and all of your virtual machines should be able to access the internet. They should be able to go to google.com, and they should be able to ping each other. Okay, so it's exactly the same process repeated. The difference is the networks that you have to advertise to your neighbors. Once you have that, you are essentially ready to move on to the next lab. So once you can ping google.com from all 3 of your virtual machines, you can, if you want to, move on to the next lab set. Or you can go to the bonus task, and you can play around with another form of packet forwarding that is not routing and is nothing. Okay, so nothing is network address translation. Who knows and can give me an example of nothing that you all use all the time in your lives? Yes?
It's built into our routers.
Exactly. Okay, so at home, you have a router that connects to your ISP. It has a public IP address of whatever class of networks belongs to your specific ISP. Okay, if you go into your routing, into your router web interface, you log in as admin, and you look for its addresses, and you look for one information, it will tell you what that IP address is. So this is what the outside world sees when they are looking at your house. Okay, your public IP address is the IP address that the router's outside network card that connects you to the wall socket actually gets. What happens inside your home is that your router gives you different IP addresses that are usually class C IP addresses, and you normally start with an address of 192.168 something, 0 something, for example. Okay, this means that your router is doing a translation from one public IP address to one or more private IP addresses. Who can think why we do this? Yes?
Increase security.
Also, it's a pleasant side effect, but not the main reason. Yes?
And then not enough public for addresses.
Exactly. Okay, so we have a few billion devices connected onto the internet at the moment. All right, and we only have a few thousands IP addresses that are public IP addresses onto the internet available. Okay, so if you live in a house and you're 4 flatmates and you each have a tablet, a laptop, and a phone, then we're suddenly looking at a bunch of devices. Okay, so in order to do this, we give the same private IP address to all of the devices behind the router, and that all gets translated to one public IP address that connects you to the outside world after that. It is also very secure because it means that nobody from the outside world can actually contact your computers inside your home, and more importantly, inside a company's network. Okay, so you're directly creating a barrier straight away that doesn't allow any outsiders to contact your computer, well, not easily at least, or find your computer easily inside your network behind your main firewall. Okay, so in order to do this, you will need to build an extra virtual machine. We're going to call it vPrometheus 3. The way to do this is very easy. You just take VP0 and clone it, just like we did in the second lab sheet. So just take the files, copy them, paste them next to the folder, and that's it. You start it up, you rename it, and then you run the fix vmnet dev script both on vPrometheus 3 and vPrometheus 0, so that you end up with the specific network cards that we want to be using for our virtual machines. So we want our vPrometheus 0 to now have two network cards, which is VMnet 0 and VMnet 3, and we want our vPrometheus 3 to connect onto VMnet 3. Once you do that, then it's the simple matter of typing one command onto vPrometheus 0 that will forward all of the packages, all of the packets that are going towards your native virtual machine from the outside world to that VP3 virtual machine. You will need to figure out what that command is. It is very easy to find it if you go online and you search for how do I do nothing in Red Hat Linux. Okay, it is only one command. It only takes 2 IP addresses and that's it. Okay, so this will be your task, which is the bonus round for this lab sheet. If you do finish everything else and you find that you do have time to do this, then you can have a go and try and implement this onto your network. Okay, however, you don't need this bonus task in order to move on to the next lab sheet, which will be DNS. Okay, so if you don't manage to do it, it's not the end of that. It's fine. It's not a problem. Okay, so to recap, what you will need to do for this lab sheet is essentially make sure that all of your virtual machines have internet access by implementing routing onto Prometheus and onto vPrometheus 1. Once you do this, then all of your virtual machines should be able to ping the outside world, google.com or whatever, and they should also be able to ping each other as well. Okay, of course it goes without saying that in any serious network, you don't actually do routing as software. You have routers and level 3 switches that can actually do this for you, so you don't need to configure this on the computer itself. However, the configuration and the commands that actually work here are pretty much the same commands that work in a terminal on any Cisco router as well. Okay, so the principles are the same, the commands are the same, and this will just help you understand how the whole process of routing works so that you understand the basic principles of it. All right. Any questions about this? Yes?
What's the difference between a class C and a class B IP address?
So the way that we split the IP addresses is what we use them for. So class A IP addresses basically go to level 1 ISPs, and then class B IP addresses will go to something like Virgin Media or whatever, and they are the most commonly used public IP addresses. So Virgin Media will allocate a class B IP address of some specific subnet, of course, onto your computer, onto your router, and then the class C ones are the private ones that we use for networks inside of our networks. And then there's multicast and other addresses like that as well. All right. If you go on to firewall.cx, it explains absolutely everything about IP addresses. Okay? Yes?
Going back to the point about having enough IPv4 IP addresses. If we already have IPv6, which can accommodate larger amounts of
Yes.
why don't we just run
So IPv6 was created exactly for this reason, because we're running out IP addresses. The problem is legacy equipment. And it's like you run a country, you run England, and you suddenly want to convince everybody to speak German. So you can have them work in tandem, so it's fine. And there are lots of ways to overcome the shortage of IP addresses issue. And the other thing is security as well. So public-facing servers are usually on private addresses that are port forwarded onto the outside world. So you don't really usually get any serious setup anymore that has one server that's on a public IP address and it's outside of your demilitarized zone so that it can be easily accessible because someone is going to hack it. So it's not that much of a problem because we are NATing and packet forwarding and firewalling everything. So really, this is one of lots of methods of hiding devices behind one IP address and securing them even more. All right. Anybody else? Yes.
One of the commands that we need to set up firewall safety.
Yes.
Command. Will we also need to make any modifications to IP tables or the UFW?
No. So this command will make whatever changes are required to the IP tables, and once you reload the firewall, that will just let the changes be taken into effect by reading the newly changed IP tables. You won't have to manually type IP tables commands. The only IP tables command that you will have to type is if you do the bonus task, because that's how you actually alter and that's how you do nothing. So you enter some new parameters in your IP tables and you get it to forward packets from one network card onto the other. Right. Anybody else? All right, that's it. Thank you very much.